good afternoon. We are graphing exponential functions today. We're starting chapter 3, which doesn't have a whole lot of sections, so we will spend a couple days on each section. We will not have a mid-chapter test, so there will be no test between the beginning and the end of this chapter. So we will have a chapter 3 test and then the final exam, and that's it for this semester. Good to know that now, okay? So this is the exponential and logarithmic functions chapter. Well, we'll learn lots of interesting stuff. And today we're going to start with graphing exponential functions. And this is the standard form of an exponential function. You know it's an exponential function because the x is in the exponent position, which makes it exponential. Got it? X in the exponent makes it exponential. Okay? And you'll notice we have a times b to the x minus h plus k. The h and the k do the same thing that they've been doing for quite a while now, and that is shifting. The h is a horizontal shift, left or right, and the k is a vertical shift, up and down, which is very, very nice. We can reflect the graph vertically as well, and that's sort of what the a does. But I have a question for you. If I have negative 2 to the x, that's a very simple exponential function. What is the value of the b? What is the b? It is 2. The b is 2. The x only affects the 2. This 2 is the base. And what's the a then? Negative 1. So it's really negative 1 times 2 to the x if you're wanting to fill it in so that we have an a and a b, all right? And it's really important that you understand that. That negative has nothing to do with the exponent, all right? And that's important because in this function, that b must always be greater than 0. We will never have a base less than 0. All right? It must be something greater than 0. It cannot equal 0. Oh, and it also cannot equal 1. That doesn't make sense to have 1 to the x. Think about that. If x is 1, you get 1. If x is 2, you get 1. If x is 3, you get 1. That's not an exponential function. That's a constant function. So we also, our b value cannot be 1. But it must be greater than 0 and not equal to 1. Okay. That being said, we're going to go ahead and do a little graphing. For all of these functions, we are going to start by graphing the base function. And the base function just goes from y all the way to the x. And what we're going to do is we're going to do a little xy chart, a very small xy chart. And most of the time you'll be able to use 0 and 1, but to get going today, I'm going to use more values so that we can remember some exponent rules, okay? But, and talk about what the graph does, but that's what we'll do. We'll graph the base function with a real easy xy chart, and then we'll go ahead and shift horizontally and vertically if we need to, okay? So here we go. Example 1, graph the base, then the function describing the transformations. Identify the domain, range, horizontal asymptote. All right, so we have y equals 2 to the x plus 4 minus 3. And we're going to start by graphing the base function. And the base function starts at the y and ends at the x. So this is our base function, like the parent graph of it. And then once we graph the base, then we'll be able to shift and graph the actual function. So we're going to start with a base, and I'm just going to do a little XY chart over here on the side. Like I said, I'm going to do quite a few values the first time through, but after that, you can use less. So I'm going to start with 0. And again, I am just graphing y equals 2 to the x. So if I have a 0 and I plug it in for x, that's going to be 2 to the 0, which equals 1. So that's the point 0, 1. If I plug in a 1, that's 2 to the first. What's 2 to the first? 2. Yeah, so there we go. And if I have a 2, that's going to be 2 squared, which is 4. Okay, so that was easy. So 2, 4. But my graph doesn't only go to the right of 0. We can actually plug in whatever we want for x. So I'm going to choose some values here to the left. So I'm going to try a negative 1. What is 2 to the negative 1? 1/2. This is why I do this. To remember, negative exponents create fractions. So we have negative 1, 1/2. And if I plug in a negative 2, what's 2 to the negative 2? 1/4. Very good. 1/4. So, oh, that's getting closer still. All right, ladies and gentlemen, what if I plug in negative 3? 1/8. Not negative, but 1/8. What if I plug in negative 4? 1/16. What if I plug in negative 5? 1/32. 1/64. 1/128. 1/256. What? 512. That is teeny tiny, right? 1/124. 1024. Yeah. We're getting smaller and smaller and smaller and smaller fractions, right? Do we ever get negative values? No, we only get fractions. And as we move to the right, we're just getting closer and closer and closer to the line y equals 0, which is, for this base function, the horizontal asymptote. So ladies and gentlemen, we did that because I wanted you to understand what was happening with those y values. They were getting closer and closer and closer to 0, but they will never touch 0, which is the definition of an asymptote. Close but no cigar. Okay. This is an exponential growth function. Growth because it is growing to positive infinity. As x moves to the right, as we have larger and larger values of x, our graph is growing up to positive infinity. If I put a negative in front of this 2, what happens to this function? It would reflect. It would be a vertical reflection, and so it would be sort of like this now. Is that exponential growth? It's my favorite question to ask.
Yeah. It's growing, but it's just growing.
Yes, it is still called exponential growth because it's growing to negative infinity. It's still becoming larger and larger. Well, in this case, negative values, but it's still called exponential growth, okay? In the negative direction is how we think about that. But that's okay. So now that we've got that talked about, I lovingly call this the Superman graph. Superman. How many of you have been to Six Flags, Magic Mountain? Yeah? You've been on the Superman ride? Yeah? What shape is that ride? It looks just like this. Guess what they used to make that ride? That equation. Yes, that equation. That is exactly right. So, all right. We need to shift this graph And you do need to describe the transformations. So describing the transformations, what is the x plus 4 going to do to this base graph? All right, it's going to be a horizontal shift, S-H-I-F-T, left 4 units. All right. And then what does the minus 3 do to the graph? It shifts down 3 units. Very good. Okay, so I can do that. So those are the words describing. That's fine. So I'm just going to take a few of these points and shift them left 4 and down 3. So 1, 2, 3, 4 to the left, 1, 2, 3 down. And let's see, I'll take this one. 1, 2, 3, 4 to the left, 1, 2, 3, whole steps down. So, ladies and gentlemen, my asymptote. Sorry. Sorry. Would be shifting as well. If it shifts to the left 4 units, does it change at all? Doesn't change, does it? It's a line that goes on forever. You shift it 4 units, you're not going to know, right? But what if I shift it down? Yeah, then it will move down. So it turns out that our asymptote always also shifts down 3 units. So we get y equals negative 3. And so it turns out that whatever that k value is happens to be your final asymptote as well. Okay? But let's just understand that it slid. It does affect the range. We're good. All right. So this green function is the actual function. Is the red function really there? No, it's just a helper. It's not really there. What is the domain of the green function? Negative to positive infinity. So domain, remember, goes how far left and how far right. This goes forever to the left and forever to the right. So negative to positive infinity. What is the range? Negative 3 to infinity. So the range is how low and how high does it go? Negative 3 to infinity is correct. Do we use a bracket or parenthesis at negative 3? Parenthesis. Why parenthesis? Right. We're never going to equal that asymptote. It just gets really close because we have an asymptote there. What's the equation of the asymptote? Y equals negative 3. All right. We're not going to equal it because it's an asymptote. All right, ladies and gentlemen, that is exponential growth. What do you think B is? Why? It's going to be exponential decay. So what determines whether something is exponential growth or decay? The B value. What about the B value? If it's less than 1, like negative values too? Great. Remember, B had to be greater than 0 by definition. So the values between 0 and 1 mean that it's a decay function. And if the B value is greater than 1, that's going to give us exponential growth. All right, so this is an exponential decay function. So, and I'm going to go ahead and make my little table here. So the equation that I'm going to start with is negative 1/3 to the x. And I'm going to start with 0. Negative 1/3 to the 0. Think about it. Negative 1/3 to the 0 equals? No. Negative 1. If you're not sure, what can you do? Use your calculator. Absolutely. Why is it negative 1? Because the negative is outside. It's out in front. 1/3 to the 0 is 1 with a negative in front. So 0, negative 1. What's negative 1/3 to the first power? Negative 1/3. So we have 1, negative 1/3. That's getting closer. If I did 2, what would we get? Negative 1/9. And then negative 1/27, getting very, very close to 0, right? Let's flip that around. Let's plug in negative 1 for x. Negative 1/3 to the negative 1 power. What do we get there? Negative 3. The 1/3 to the negative 1 flips the fraction, becomes 3 with a negative. So negative 3. So negative 1, 3. Whoops, sorry, negative 3. It's like, fooled you. Okay. Okay. And then we would get negative 9 and negative 27 and so on and so forth. An exponential decay function means that as x moves to the right, as x gets larger and larger and larger, the y values approach 0. And that would be the asymptote. And so that's our asymptote y equals 0. So that is the actual definition of decay, that as x goes to infinity, y goes to 0. Versus out here on the growth, as x goes to infinity, y goes to infinity, or negative infinity. So we want to shift this. How does it get shifted? Yeah, up 4 units. So 1, 2, 3, 4. And up a whole step, up a whole step, up a whole step, up a whole step. 1, 2, 3, 4. And so what happens to our horizontal asymptote? It gets shifted up 4 as well. And we're here at y equals 4. Make sure you draw in that asymptote before you connect your dots, because you don't want to touch it. You'll die. Okay. Domain. What's the domain of this function? Negative infinity to positive infinity always. What's the range? Negative infinity to 4. Bracket parenthesis. Parenthesis. What's the horizontal asymptote? Y equals 4. Very good. Ladies and gentlemen, do you have questions on the graphing? Yeah. Are we done? No, not quite. All right. There we go. Example 2. Use the one-to-one property. The one-to-one property is this. If b to the u equals b to the v, then u equals v. We use the one-to-one property a lot. Actually, it's really just the property of two things being equal. If something matches, shouldn't the other stuff also be the same? Yes. So that's the basic understanding here. I like to point out the property just of all things being equal a lot. It's a good thing to pay attention to. So this basically says if the bases match, if your bases are the same, then your exponents can be the same too, or must be the same, if you will. And so if we have 9 equals 3 to the x plus 1, what I want to do is try to rewrite something so that I have the same base. So here I have a base of 3. It's a nice small number. That's great. I think I'll keep that. But I would really like to trade in the 9. What can I trade in the 9 for? 3 squared. Very good. So now, since the bases match, what must be true? The exponents must match. So 2 must equal x plus 1, which means x equals 1. Brilliant, folks. All right. Today's are real easy like this. Tomorrow we get to do some real fun stuff. Like this is easy. Tomorrow's is super awesome. Okay. So again, 2 to the x times 1 over 32 equals 32. I want to again think about rewriting things with the same base. So I have a nice base of 2 there. So I think I'll keep the nice 2. And what I'd like to do is trade in the 1 over 32. What can I trade in the 1 over 32 for? 2 to the negative 5 power. Very good. Negative exponent, fraction. 2 to the 5th, 32. Equals, and again, can I trade in the 32? 2 to the positive 5. There we go. All right, now we've got some properties of exponents here. If two things have the same base and a product, what are we allowed to do to their exponents? Add them. So this turns into 2, base stays the same. Add your exponents, and what do we get? X plus a negative 5, which is really just x minus 5, equals 2 to the 5th. And now if the bases match, then the exponents must match. So x minus 5 equals 5, which means x equals 10. Bueno. You have any questions? You will finish your assignment before you leave today. It's an order. Do you understand? Okay.
What?